All right, so we're continuing on our 6-7 notes, and we are starting on example 2. And our directions tell us to write an equation for the line that contains the point, -2, 3, and is parallel to the line y equals 5/2 x minus 4. First thing that we need to remember is if we want to make a parallel line, parallel lines have the same slope. So I want to look at my equation here and figure out what's my slope. 5/2 is my slope, so I know that my slope has to be 5/2. My slope must be 5/2. And it has to contain this point right here, -2, 3. So these are the two criteria that it must meet. Now, because this equation right here is written in slope-intercept form, we need to write our equation in slope-intercept form as well. That's our overall goal. But currently, I'm given a point and I'm given the slope. And we recently learned about something called point-slope form. So I'm going to start, since I know a point and I know the slope, I'm going to start by putting this in point-slope form, which is y minus y1 equals m times the quantity x minus x1. So we're given a point, we're given a slope, it's going in point-slope form first. So for y minus y1, I'm going to do y minus 3 because my y value is 3. My m is 5/2 times the quantity x minus, and it's going to be x minus a -2. So those two negatives are going to create a +2. So I'm going to go ahead and make a +2 right off the get-go. So we put it in point-slope form because we were given the point and we were given the slope. But because this is written in slope-intercept form, our answer has to be in slope-intercept form. So we actually learned the other day how to convert point-slope form to slope-intercept form. Eventually, I want to get this y all by itself. But before I can get rid of this -3, I have to use my distributive property on the right side. And I get 5/2 x plus. When I multiply 5/2 times 2, those 2's cancel. And I get 5. And I've still got y minus 3. Now to get y by itself, I can add 3. And I get y equals 5/2 x. And you'll notice I line the +3 up underneath my other constant here. And I get +8. So this is my equation. And those two lines are going to be parallel because they have the same slope, 5/2 and 5/2. So I'm going to have you guys pause the video here. And I want you to go ahead and practice. You've got these equations in slope-intercept form, so your answer should be in slope-intercept form. And you need to make a line that is parallel to this line using this point. So the first thing I'm going to do is identify my slope. My slope in this example here is 6. So I'm given a point and given the slope, I'm going to start with point-slope form. For y minus y1, I'm going to do y minus 0, which is just y. My m is 6 times the quantity, x minus, and I get 0 here. And I can distribute that 6 to my parentheses. 6 times x is 6x. 6 times 0 is just 0, so you could write +0 if you wanted to. But typically we wouldn't write the +0 at the end. We would just say that our equation of our line is y equals 6x. And again, my slope is 6, my slope is 6, so we know that those two lines would be parallel. Now for question number 15, my slope is -2. So I know that m is equal to -2. I know my point, I know my slope, so I'm going to put it in point-slope form. I hope you're catching the drift. We know a point, we know the slope, point-slope form. So instead of y minus y1, I'm going to do y minus 5 equals m is -2 times the quantity x minus my x1 value is a -3, so those two negatives are going to create an x plus 3. Now we put it in point-slope form because we were given a point and we were given the slope. But this equation is slope-intercept form, so our final answer should also be slope-intercept form. In order to get y alone, I'm going to have to add 5. But I can't add the 5 until I first apply the distributive property. So when I do so, I have y minus 5 equals -2x minus 6. And now to get y alone, we add 5. Y is equal to -2x. Adding my constants, -6 plus 5 gives me -1. So my slopes are the same. They're both -2.